Hey guys, so we have finally come to the end of not only our giant flow chart, but also the end of this chapter and the end of this unit. So we're going to be finishing off strong with a nice short lesson on the pancreas. Okay, so the pancreas is an organ that we've already talked about in terms of digestion, but now we're going to talk about it in terms of the endocrine system. So the pancreas is actually part of more than one organ system. So we're going to talk about the function of the pancreas. We're going to talk about its different types of islet cells. We're going to talk about the hormones of insulin and glucagon and how they affect the body. We're going to talk about what the disorders of hypoglycemia and hyperglycemia are, as well as type 1 and type 2 diabetes mellitus. So the pancreas actually works mostly as an exocrine gland, and that is its like digestive function, where it's like secreting digestive enzymes and stuff like that into the small intestine. But the pancreas does also work as an endocrine gland because it has specialized endocrine cells. These specialized endocrine cells are found in islet cells. They're just like little clumps of cells, also called the islets of Langerhans. I probably pronounced that wrong. Islet cells produce and secrete hormones that help regulate blood glucose levels. So in this picture here, this is the stomach up top, and then underneath we have the pancreas here. And all of like this like green area here and here and here, that's all like the digestive portion of the pancreas. And these are like the little like ducts that are typical of exocrine glands. But these little purple areas are the islet cells, the cells that are part of the endocrine portion of the pancreas. There are two different types of islet cells. There are the alpha cells and the beta cells. The alpha cells secrete glucagon anytime you have low blood glucose levels. The beta cells secrete insulin anytime you have high blood glucose levels. So these two hormones of insulin and glucagon actually work against one another to kind of balance out your blood glucose level to maintain that homeostasis. And both of these hormones are, of course, secreted into your blood. So insulin, again, that's the hormone that is released when your blood glucose or blood sugar levels are too high. They will be released by the beta cells of your pancreas. The insulin then travels around through your blood and is going to attach to receptors on your liver and skeletal muscle cells. It's going to cause the liver and the muscle cells to absorb glucose from the blood and store it as glycogen. It's also going to cause your adipose tissue, which is your fat storing tissue, to start storing some of the glucose in your blood as fat. And it's also going to make all of the cells of your body more permeable to glucose, meaning that more glucose can go into your cells. And so all of that will result in your blood glucose levels going down. So this is your pancreas. Again, it's going to secrete insulin. The insulin is going to cause your liver to store glucose as glycogen. It's also going to cause your muscle cells to store some of that glycogen. And it's going to cause your adipose tissue to store the glucose as fat. Also, it's not shown on here, but also going to cause all of your cells to be more permeable to glucose. The glucose goes into your cells and out of the blood. Glucagon is the opposite of that. So if your blood glucose levels get too low, the glucagon will be released from your alpha cells. It is also going to travel through the blood to your liver and your adipose tissue. The liver cells will convert that stored glycogen back into glucose and release that into your blood. Your adipose tissue will break down the fat into glucose and release that into the blood. And so your blood glucose levels will go back up again. So these do, again, work in contrast to one another. So if your blood glucose levels go high, your beta cells are going to release insulin, which again goes to your liver. It's going to go to your adipose tissue. It's going to go to your body cells and make them more permeable to glucose. all of that is going to result in a decrease in blood glucose levels. If your blood glucose levels go the other way and are too low, your pancreas's alpha cells will release glucagon, and it's going to go to your liver and your adipose tissue and cause them to essentially break down their stored glucose in the form of glycogen for the liver and in the form of fat for the adipose tissue, but it's going to break down and release that glucose back into the blood, which will then bring your blood glucose back up to normal again. Hypoglycemia is a condition where someone's blood sugar is too low, usually caused by their pancreas producing and secreting too much insulin. People who have hypoglycemia have to essentially have a bunch of little tiny meals spaced out throughout the day, all with very little sugar in it, so that they don't stimulate the release of insulin from their pancreas. People with hyperglycemia have the opposite problem. Their blood sugar is too high, usually because of a lack of insulin. So at that point, essentially, their blood glucose levels are so high that the kidneys can't reabsorb all of the glucose and like back into their blood, and so they end up with glucose in their urine. Having glucose in your urine is not normal. That is a sign of some sort of disorder that's happening, and it is going to cause water to also go into your urine that's being produced, because it's just following the dissolved stuff, and in this case the dissolved stuff is the glucose dissolved in your urine, and so it makes people with hyperglycemia pee large amounts of dilute urine. Diabetes mellitus is essentially just the group of symptoms caused by hyperglycemia, so it includes, as we talked about before, things like frequent urination, having like large amounts of dilute urine, being thirsty all the time, having glucose in their urine, being tired, losing weight even. In severe cases, it can result in blindness, kidney failure, gangrene, nerve damage, and even death. Again, this is caused by a lack of insulin or insulin just not being able to be effective. And since insulin causes cells to become more permeable to glucose, people with diabetes mellitus have a hard time getting glucose into their cells because without the insulin, the glucose doesn't want to go into the cells. So even though there's a lot of glucose in their blood, that glucose is not able to get into the cells where it would then be turned into ATP energy, which is why people with diabetes tend to be really tired all the time. There are two different types of diabetes mellitus. Type 1 is when the beta cells of the pancreas are destroyed by the person's immune system, so the patient can't produce insulin. This usually starts when the person is a child and they will require daily insulin injections. Type 2 diabetes mellitus develops later in life. It's usually in people who are overweight and or underactive. Essentially, the liver cells stop making insulin receptors. So even though their pancreas is still producing insulin, it doesn't have the appropriate effect on the liver, and it can often be controlled with diet, exercise, and medication. So when people just say they have like type 1 or type 2 diabetes, they are referring to diabetes mellitus, the one that has to do with insulin. Diabetes insipidus is different. It has to do with ADH not working properly. Okay, so we are finally at the end of our giant flow chart. So with the pancreas, we have both the beta cells and the alpha cells. If you have high blood sugar, it will stimulate the beta cells of the pancreas to release insulin. Insulin is going to go to your liver and muscles, cause them to absorb glucose and store it as glycogen. It's also going to go to your fat cells and cause those cells to use the glucose to make more fat. And it's going to go to your body cells, cause them to increase their permeability to glucose. And all of that is going to work to lower your blood glucose levels. If you have low blood sugar, that's going to stimulate the alpha cells of your pancreas to release glucagon. That's going to go to your liver, and cause the liver to convert glycogen to glucose. It's also going to go to your fat cells and cause them to break down into glucose, all of which will raise your blood glucose levels. Okay, that is it for this unit.